Hello everyone, I'm Abu Bakr Abid and I'm one of the developers behind Gradio. So Gradio is an open source library that lets you easily build interactive UIs and applications for your machine learning model. Gradio is an open source repo, which means that we've open sourced our code, anyone can take a look at it, and also anyone can contribute to it. And so far, as of the end of 2022, we've had more than 100 different contributors to Gradio. I've also had a lot of requests from potential contributors on how to get started, on how to contribute something to Gradio. So I decided to put together this video as kind of an overview of, let's say you don't really know too much about Gradio, to all the way to being able to build a change to Gradio, make a change to Gradio, and create and contribute that back to the Gradio code base. And so the goal of this video is three things. First of all, starting off with talking a little bit about how to use Gradio. So what is Gradio? Kind of the basic usage and syntax. If you already know how to use Gradio, you can skip this part. The second part is an overview of the Gradio code base. So kind of just walking through the main files, and particularly on the Python side. I'll focus on the Python side since that's where I've had a lot of requests coming from. But Gradio consists of both Python and JavaScript side. And then finally, the kind of the more mechanics of contributing to an open source repo on GitHub. So how do you go about creating a pull request, that kind of thing. So let's get started. So I'm going to kind of just start off walking through some things. So this here is the Gradio website. And so the Gradio website is gradio.app. And you can see a bunch of things here at the top, in particular the quick start, which is, I'm just going to walk us through the quick start. Again, if you already know how to use Gradio, especially if you know how to use Gradio interface and Gradio blocks, you can kind of skip this part. But if you don't know how to use Gradio, we'll cover everything starting from pretty much nothing. Okay, so first of all, how do we even install Gradio? So the way you install Gradio is just like how you install any other Python package, pip install Gradio. So you just copy this, go to your terminal, type in pip install Gradio. In my case, I already have Gradio installed, so it's just going to say requirement already satisfied. But if you don't have Gradio installed, it should go ahead and install that for you. Then we're going to go ahead and run some basic kind of a hello world of Gradio. And I'm going to be running this inside this Jupyter notebook. Gradio runs anywhere. So if you run Python inside terminal or wherever you run Python, this should work just fine. But I'll run it inside Jupyter Notebook. It's a very handy way to use Gradio. So let's take a look at this code before I run it. So what is this code doing here? So first of all, I'm importing Gradio. Second, I have a very, very simple function here. It's called the greet. And the greet function takes in a string, and it just says hello, followed by the string, followed by an exclamation mark. And now I take this function, and I pass it into the Gradio.interface class. Now, so this is where basically, this is like the core class in Gradio that you need to know about. So Gradio interface, interface is the core class. It takes in three arguments, three necessary required arguments. So the first one is a function. So in this case, it's greet. The second one is what kind of UI you want for the input. Okay, on the input side, what do I want? Well, since this is kind of a string-based function, the natural UI here for me is a text box. So you can type in text, inputs equals text as a string, and we'll come back to this. Outputs is also a text box in this case, so I'll go ahead and pass that as text. And then once I've instantiated my Gradio interface, I can go ahead and launch it. And let's go ahead and run this and see what happens here. So I'm going to go ahead and run this Python cell. And what you'll see is something that's, let me actually zoom out a little bit just so you can kind of see this all in one line here. So what's happened is I have a server that's launched on local port 7860. Okay, what is running on that server is a little web app right here. Okay, so you see this little GUI here, this little application. It's inviting me to type in a name here. So let me type in my name, Abu Bakr. You can see here, hello, Abu Bakr. So nothing too complicated here. This UI is just a wrapper around the function that I passed in. Okay, so Gradio.interface lets you create a UI around whatever function you have. Okay, but you might want to customize the look of this UI a little bit. You might say, okay, this is fine, but maybe I want the size of this text box to be a little bit different. Well, in that case, then you stop using the string shortcuts that we have here, and we instead use the full name of the class. Okay, So the full name of the class is actually a text box. Okay, so you can see all of the classes. If I go back to the Gradio website, I can see all of the classes here. So you see where it says components. So this is a text box, this is a number slider, all of images, video, audio, all of the type of standard components that you probably want to use for your machine learning model demo, you can find here in Gradio. And so if we go to text box here, so text box is obviously a very important one, and you can see how it looks right here. But what you can also see is you can also see the parameters, and these parameters are important because they let you customize the look and feel of your text box. So for example, I want the number of lines to be maybe 4. Okay, so now I have a bigger text box here. Maybe I want to add a placeholder here. Okay, so I can add a placeholder that says here, enter your name here. And then you can see that here as well. So now I have a little placeholder. It still works like it did before. If I type in my name, it's still kind of wrapping the same function that I provided because I haven't changed the function. Okay, so and then you can see the string shortcuts and various things like that, and various like derivative classes based off of the text box. So for example, if you have text area, it's like a text box, but it has 7 lines, for example. Okay, so this is kind of like a basic example of how you use text boxes, but of course you can do a lot of other things as well. So let's take another example here. So I'm going to go down, and I'm going to go to this next example here. So this example is a little bit more complex, okay? And well, let's start off by taking a look at our function. So it's still called greet, but you can see now it takes in 3 different parameters. It takes in a name, it takes in a Boolean parameter called isMorning, and then it takes in a numerical parameter temperature. And what it does is it basically converts that temperature from Fahrenheit to Celsius, and then it gives you a greeting based on let's see here. Oh yeah. It basically takes in it gives you a greeting based on if it's morning or if it's night. Anyways, let's go ahead and run this. But you'll notice, by the way, that the function takes in 3 inputs and it returns 2 outputs. For Gradio, that's very easy to handle. You just pass in a list of inputs and a list of outputs. So we'll go ahead and run this, and you can see what's happened here is, again, I have a more complex UI here. Now I have 3 different inputs here, and so I can type in a name, I can check, yeah, it is the morning, and I can put in a temperature. And now what's going to happen is going to say, good morning, Abu Bakr, it's 40 degrees today. And you can see here it's converted that temperature into Celsius, whatever it may be. So the 3 inputs appear on the left, the 2 outputs appear on the right. Everything is kind of passed and connected together, and Gradio takes care of that. Now let's take a look at maybe an image example, because of course I think the power of Gradio really comes in with these kind of rich type inputs like images, videos, and so on that Gradio can easily handle. So this is a function that takes in an image, and you can see the input here, we've said Gradio.image, and we've passed in a shape parameter. Now this is important because the various parameters, they can be used not only to customize the look and feel, but also to do a little bit of pre-processing. So if we go into image and we look into its parameters, you can see that image has a parameter called shape. Okay, I missed this, which takes in a tuple, a width height to shape, to crop and resize the image to. So basically what this means is that when I pass in this image, when I drag and drop an image here, so I'm going to just pick an image here, let me just put an image of myself here, it's gonna crop my image to be 200 by 200 before it even passes it into my function. Okay, so this is pre-processing. There's also some default pre-processing which converts an image to a NumPy array, right? Because when I drag and drop an image, I need to convert it into some format that my Python function can interact with. By default, that's a NumPy array. You can also change it by using the type parameter and change it from NumPy to something else like pill or file. You can pass in the input in various different formats. But right now, by default, it's a NumPy array, which is very convenient because my function takes in my image as a NumPy array, multiplies it by this sepia matrix, and you can see here it's applied like this sepia, this kind of yellowish filter to the output image, and I get out a 200 by 200 output image of myself. All right, so you can see here Gradio takes care of the conversion of the input into an appropriate format that your function can take in. And when your function returns an output, Gradio automatically figures out, oh, okay, this is an NumPy array, but for my browser, I need to convert it to an image format. So it automatically converts it from a NumPy array to an image, to a base 64 image that the function that the browser can display. Okay, and then Gradio has many other input types, output types. You can play around with that. I highly encourage you, if you're planning on contributing to Gradio, to go through the quick start and go through these examples. I'm going to kind of just talk about blocks as well, because I think blocks is very important too. Because you can see here, Gradio.interface, that's the key class we've been talking about, but it's fairly restricted in the look of your UI. You have the inputs to the left, the outputs to the right, and when you run the submit function, it passes it through your function. You have a single function, it's a single flow of data from input to your function to the output. Blocks gives you a much more flexible way of defining your UI. It's basically a whole language of how to create web applications in Python. And the way that it works is, again, you kind of start off with a very simple function. In this case, it's greet. But I should mention, by the way, these functions don't have to be simple. I've been giving very simple examples for the purpose of this tutorial, but typically these are much more complex functions. They're machine learning prediction functions. But for now, let's just start with this one here, greet. And now with blocks, what you do is kind of you just go through and you just define the components that you want. You say, okay, first of all, I want to start off with a text box, okay, and I'll just give it a name called name. Then I want an output text box, and then I want a button. So let me just go ahead and run this first. So you can see here with blocks, I basically create the components in the order that I define. So I want a name text box, then I want an output text box, then I want a button called greet. Okay. Now you don't have to go this kind of column format. You can also put everything in a row. You can mix up rows and columns and things like that. This will put everything in one row, for example. Use kind of with as to construct everything. You can see name here, and this big greet button. You probably don't want that. Maybe you want the first two things to be in a row, but then you want the button to be on the next line. So you can kind of figure that out, because there's kind of this intuitive format, but using with and this scoping. So let's do it like this. Now I need to define something. So I want to say that when this greet button is clicked, then I want when this greet button is clicked, I want to run my function, which is called greet, using the input as the value in the text box, in the name text box, and the output as the value in the outputs text box. So if I go ahead and run this, I can see here what's going to happen. Oh, I need to rerun this because now I've added this event listener here. And now if I do this, it should work. It'll just say hello, Abu Bakr. So you can use blocks as a much more custom thing. You can add many different event listeners. You can have many more flows of information. It's a lot more flexible than the Gradio interface class. It gets a little bit kind of getting used to, just because you may not have worked with these with clauses before, especially in the context of Gradio. But once you realize how it works, it's very intuitive, very easy to build the type of UI that you want. Okay, so I definitely encourage you to go through and go through this quick start. Read about the key features in Gradio. There's a lot of cool things like adding examples and so on, and sharing your app. So basically this entire getting started block is going to be very valuable. And if you have time, you can read more on building interfaces, and you can read more about building with blocks as well. A lot of it is very useful information that'll be helpful when you're trying to kind of read the code base and understand what the different pieces are. Okay, so one thing that I'll just mention here, one cool thing about Gradio that if you don't already know, you can also create a share link very easily. So let's say you've built a Gradio demo, you like it, it's working great, and you want to share it with somebody else. You can add a share equals true in the launch argument that we saw here. You can just type in share equals true, and it'll create a public link, like a Google Docs link, that will let anyone try out your application in their own browser. So it continues running in your local environment, but someone else can access it in their browser, which is very handy if you're prototyping and want to share something with a colleague or with a customer or whoever it may be. Okay, so let's go ahead and I think, transition now. We've talked about what Gradio is. Let's now talk about an overview of the Gradio code base. So I'm going to kind of just transition here now. Let me open up Visual Studio, which is what I use. All right, cool. So what I want to do now is I want to give you a kind of an overview of the Gradio code base. And the Gradio code base is actually, you know what? I think the better place to do this is on GitHub. I think it'll just be a little bit easier to see the folders and whatnot. Okay. So the Gradio code base, I mean, of course, it's a reasonably large code base at this point, but there's a lot of stuff that isn't too relevant if you're trying to contribute. So first of all, what are the different folders here? So the first three are just kind of some of these internal things. Demo. So demo is a folder that just has a bunch of demos. It has, at this point, I don't know, a lot of different demos that are built with Gradio. So this is useful because we reference these demos in different parts of the documentation, but it's not something you really need to kind of worry too much about when you're contributing. The Gradio repo, the Gradio folder inside the Gradio repo is where all of the Python code lives. So we're going to dive into this shortly. Guides consists of documentation. Same with a lot of these other things. Scripts is just handy scripts for kind of development. We'll come back to this as well, actually. Tests, this is where all of the Python tests live. And UI is where all of the front end lives. Okay, so this is the front end JavaScript code. I won't talk about this too much in this overview, just because I'm going to focus on the Python, the backend side. And then finally, we have this website here, the website folder. This contains the source code for Gradio.app, the actual website. So this is a mono repo. It contains everything from demos, documentation, the website itself for Gradio, and then of course all the code for Gradio. So let's jump into the code itself. So when you look at the code, there's a lot of Python classes here, and it's easy to kind of get intimidated. But don't worry about trying to understand everything. We're just going to kind of focus on some of the key important classes, the key important files or modules. So let's start with this here. So you have the Gradio the components.py file. Now this contains all of the code, again, all of the backend code for all of the components that we saw. So let's find the text box class, right? So let's go there. All right, so here we go. Text box was the component that we were working with earlier. Okay, and so you can see here when you instantiate a text box, all of the different parameters that you can edit. So these are the things that we saw earlier. You can change the number of lines and so on, and this instantiates them. Every component is a subclass of this IO component class. And so the IO component is like this parent abstract class that contains, you know, the basic methods for every component that can be used as an input or an output. And so you can see that here. You kind of save these parameters and you instantiate the parent class. You have this getConfig method, which is basically, you know, when you create a text box, it defines itself, you know, based off of the properties that you've provided, and it sends this JSON config to the front end, and that's how the front end uses this config to render the right UI. Pre-processing and post-processing. So this is actually pretty important. So the idea is, you know, your function is going to return something, and then or the front end is going to return something back to the back end, and the back end is going to pre-process this in certain ways, right? And so let me give you another example that might be a little bit easier to parse. Let's go to, like, for example, the number class. Okay, so the number is another component in Gradio. And so number, let me show what it does first before okay, so let me define a very simple. So let me do identity. It just takes in a number, just call it X, it returns X, okay. Now I can create a Gradio.interface here, interface. It runs identity, and it uses a number as the input, number as the output. And let's go ahead and launch it. And so if you run this, you'll notice that it created this number interface, and it kind of just runs this. Input is 3, output is 3. Obviously, it's very simple. Input is 3.44, output is 3.44. Now, if you look at the pre-process and post-process, you'll see here it says here, return self.round to precision based on the precision of this function based on the precision of this component. And what that means is when I create the number, I can provide a precision for it. I can say something like precision equals 2. And what this will do is this will pre-process whatever I type in so that it only has 2 decimal points. And you can see that here. The identity function returns itself, but before it even gets to the identity function, it pre-processes it to have 2 decimal points. So you only see 2 in the output. And so pre-process and post-process are very important. For things like images, they set, should be pre-processed into a NumPy array or a pill format, depending on, the parameters that we're used to construct that image component. And so you can see all of the different components here, everything that Gradio supports. Now I'm looking at the image, I'm looking at the video, and so on. If you're curious about what these are, these basically refer to the event handlers that this particular component supports. So if you remember with blocks, we use event handlers. And so let's go back to text box, class text box. And so you can see here, for example, it says the text box is changeable, submittable, blurrable. What does that mean? That means that if I define a Gradio blocks, I can say something like this. I'm going to go ahead and run an input text box. I'm going to create a text box called I. This is for the input. And then I'm going to do one for the output. So demo.launch. I haven't defined demo yet. Let me go ahead and do that here. So this is going to create 2 text box, right? We saw this with blocks. It just kind of follows in order of what you've created. But these text boxes don't do anything right now. But what I can do is I can say I.change, run the identity function using I as the input and O as the output. Okay, so this is my function. This is my inputs. I'm just adding these parameters for clarity. And so what this is happening, what this is going to do is now every time that the text box changes, the input text box changes, the output text is going to rerun this event handler, and I'll see the result on the output. So in other words, the text box component supports this change event listener. It also supports a bunch of other ones. So submit, meaning if you press the enter key. Blur, if I leave the component. So let's try blur, for example. Okay, so if blur. So if I type in ABC, then I remove my key. Remove the focus from this text box. That's going to rerun it. You can see that here. It's doing that. And so you have a bunch of different things here. And so the components.py is a very, very important class that contains all of the information about all of the components. All right, so let's keep going. So blocks is a very important class as well, important Python module that contains the definitions for what a blocks is. So, so block in Gradio, there's 2 different things in Gradio. A block, which is like any particular component. So like, text box or things like that. But then there's blocks itself, which is like what you build out of individual blocks, right? And so it has a definition for that as well, and you can kind of read that and see how that works. So if I go to class blocks, so this is the low-level API, and so you can see usage examples here and all of that. And by the way, so the Gradio documentation, it's built directly from the doc strings here, of course. So if I go to the documentation here, I'll see the same thing. Like if I can see the blocks here, I can see the example usage. All of this is built using this documentation tag. But anyways, okay. So the blocks here. Context, it contains some global variables that are useful. It's actually not too important of a class. Data classes just define a few typed classes, not too important here. Deprecation is just, again, not important. It just is how we deprecate stuff. Documentation, this is kind of links the Gradio code base to the website. Encryptor, not important. Events define all of the different events, so things like blur or change and all of that. All of the methods for those are defined here. Examples is relatively important. So one of the things Gradio supports is creating these little examples that can appear under your Gradio interface or in different places in blocks. And so the code for that is in examples.py. Exceptions, it just defines a few custom exceptions. External.py contains the code to load things from Hugging Face spaces and Hugging Face, the model hub. So if you're working with the model hub or any sort of integration between Gradio and Hugging Face, you'll probably find the code for that in external or external utils. Flagging. So we haven't talked about flagging too much, but you may have noticed under every Gradio interface, there's this flag button. So if I go back and create this interface that you saw earlier, there is this flag button. And what this does is it actually, like, let's say I run something, but I'm not satisfied by the input. I can click flag, and it actually saves that data point locally on the computer that is running the Gradio demo. So it's very handy if you send your interface to somebody else, they can try it out, they can flag stuff, and it gets sent directly to you automatically. And so flagging.py does that. Inputs is actually deprecated, so you don't have to worry about this entire file. It's only preserved for backwards compatibility. Interface has a lot of the code for the core Gradio interface class. Now, what's kind of cool is that Gradio.interface is itself just a subclass of blocks, right? You'll see that here. So Gradio.interface is a subclass of blocks. And so what that means is if you understand blocks really well, interface kind of just flows from there, and you don't even have to mess too much with the interface class. Like most of the key thing is like understanding blocks, which is kind of the core, API for the core low-level API. Interface itself is built out of blocks, to put it another way. Interpretation is kind of an advanced thing. I won't talk about it too much right now. There's an IPython extension that Gradio includes, which is here, not too important. Layout. So this is important. Again, if you're working with blocks, you have a lot of control over the layout. So you can define rows, columns here, tabs, and so on. And so that's all defined in layouts.py. I'm going to skip. This is mostly just for testing media data, so you can ignore that. Mix is if you want to put Gradio.interfaces together in series or in parallel, you can do that here. Networking.py is an important one. This contains a lot of the code for spinning up the local server that runs the Gradio demo. Depending on what issue you're working with, you may or may not need to use networking.py. Similarly with routes. So routes define all of the routes in this local server. It basically defines your fast API server for you. Let's see here. Outputs is deprecated. You don't have to worry about that. Pipelines, this is for our integration with transformers. So if you're working with the integration with transformers, you can take a look at this. Otherwise, it may not be useful. A lot of utility functions here. Queuing.py has a lot of the code for the queue. So if you enable the queue, you'll see I'm in position 8 out of 20 in the queue. All of that code is here. It's pretty interesting. And then we go down to serializing. This contains not too much code, but basically the code for how to send the data from the Gradio. Like if you're, for example, saving stuff into a CSV from a component, this handles all of that stuff. Strings is just define some hard-coded strings, not important. Templates is kind of interesting. This is what I was mentioning at the beginning, where you have variants of components as well. So you have a text area. All it does is it takes it takes the text box component and sets lines equals to 7 by default. And so it does that, and everything else is kind of just works. Tunneling. So this is the code for the share equals true, how that's created. Utils, a lot of utility functions. And that's it. That's all of the Python code. And then tests contain files for each of these that test each of the modules, as you would expect. Test blocks, tests blocks.py, and so on. And these are all written in PyTest format. So if you're familiar with PyTest, these should be pretty straightforward. And that's it. That's pretty much an overview of the code base. The last thing that I want to talk about is how to actually make a contribution to Gradio. And so we use GitHub for everything. And so a place to start might be if you notice a bug in Gradio, what you can do is you can create an issue for that bug, and then you can try to solve your own issue. Or what you can do is you can find an existing issue, and if you want to just contribute to Gradio and you don't have a particular issue in mind, you can try to find good first issues. And so this comes up when you do good first issue. You'll see a bunch of different issues here. They're also tagged by if they're bugs or if they're enhancements to the library, if they're front end or if they're back end, and so on. We're going to focus on backend. And so let's take a look at this issue just as an example. So no backend validation for form limitations. And sorry, by the way, I should say is like these were manually tagged as good first issues. Don't feel like you have to restrict yourself to these issues. If you find another issue that you feel like you're comfortable taking on, that's completely fine. Of course, we're totally welcoming all sorts of different contributions. So no, let's take a look at this issue though. No backend validation for form limitations. So what is this issue talking about? So it's basically saying that on the front end, you can set things like the values of a slider. And let's just see an example of that. So I'm going to create a slider here. I'm going to say the minimum is a 0, the maximum is 100, and the output is going to be just a number, let's just say. Okay, so you can see here, I can set whatever value I want as long as it's between 0 and 100, right? I cannot go above 100. The output is going to be whatever I put inside. But what this is someone is saying is you could, so what happens when I run this, right? So what happens when I run this is let's go to network. A network request gets sent that actually sends the data, 39 back to the backend server that's running, and the server returns the output. So the server is what actually runs your function, and it returns the output as 39 in this case, and it kind of just predicts it here. Now the thing with this is that it's not going to be validate on the back end that so basically what could happen is you could manually send a request to the back end, and you could say, hey, the input is actually 205, and it's going to run the function assuming your input is 205 and give you an output which is going to be 205. Okay, now this isn't a problem if you have a function like this, but if your slider contains something like the example that they gave here is they're using sliders to run the inference function for a number of steps. And they're worried when they host it on their website or on Hugging Face Hub or wherever you can host Gradio demos, they'll worry that people could manually surpass the limit that you set in the front end. And so in other words, what we need to do here is actually we need to go to the slider component. So we can go back to, I'm going to open up VS Code now so I can edit this code easily. So I'm going to go to the slider component, and I can say, hey, let's go to def preprocess. Let's go to slider component first. Class slider. Okay, I'm in the slider component, and if someone sends to the backend, okay, so first of all, where is the preprocess function in slider? Turns out slider doesn't have one defined, and the reason for that is because it inherits the preprocess function from IO component. The preprocess from IO component is basically just says, hey, if whatever value I get, just go ahead and return that value. Okay, so if my input is X, the output is X. Okay, so for slider, it's the same thing. But maybe I want to actually be smarter in my preprocessing. I want to say that if someone returns a value that's higher than my minimum, higher than my maximum, or lower than my minimum, I raise an error, Or instead of raising an exception, what you could do instead is maybe trim the value to be between 0 and 1, your minimum and your maximum. So you can do whatever you want. In this case, probably raising an exception makes sense to prevent people from, abusing this, and so that there's clarity, so that a person knows, why it failed. Okay, so let's say you have a fix. So how do you actually go ahead and submit this to Gradio? Well, we have a contributing guide that you can check out. So if I go to the code base, if I go to contributing.md, it tells you all of the stuff that you need in order to contribute to Gradio. It looks like a lot, but it really isn't actually as much as you think it would be. First of all, you need to have Python installed, obviously. Any version of Python 3.7 plus is supported. We typically use Python 3.9 or 3.10 for development. You also need PNPM if you're making front-end changes. Since I'm focused on the back end, I won't worry about this. So what you do first is you install Gradio locally from the main branch. So you go ahead and clone this repo. So I have already cloned it, but if you had not cloned it, what you would do is you would just go to the code here. You would find the URL for this, and you would go ahead and clone this. Okay, so you clone the repo. Then you navigate to the repo folder. So I've navigated to there. So I'm inside the repo folder. You can see that all of this stuff here, Gradio, guide, scripts, test UI, all of this stuff is over here. And so what you do is you go ahead and you run this script here. Script install Gradio. And it's actually best to run all of this. So all of these scripts, they should mostly work in any OS, but we actually set them, you know what, let me go ahead and do this on WSL. So I'm running on a Linux subsystem. And so you can go ahead and run this script from here, and this will go ahead and install Gradio. It may not work because I've already have it locally installed. Okay, or it should work. Yeah, so all it's doing is installing Gradio locally. So instead of installing it from PyPy, it's installing it from the GitHub repo, from the files in the GitHub repo. Then I go ahead and I build the front end. So this I need to do if I want to see my changes. So this is, if you're making front end changes, you have to do this. If you're only making back end changes, you don't have to. So I'll skip this because I'm only doing back end changes. Okay. And then in order to run the Python test, you might have to install some additional requirements. I already have them installed, so I won't run this, but otherwise you could go ahead and do this. For this, we highly recommend that you're running Python 3.9 if you're going to make changes to the test or add any tests, because we've pinned all of the versions to make it super reproducible. Okay, and let's go ahead and start doing things now. So I can start. I'm going to get out of here, and I can go ahead and see that I'm in the main branch here. I'm going to go ahead and create a new branch for my changes. So I'm going to make one called validation fix. So I'm making a fix to this whole validation thing. Now I can go ahead into my code base and I can say, okay, I'm going to make some changes here. Let's add a pre-processing method to slider. So I can add a pre-process method. So it won't use the one from IO component. I'm going to go ahead and do float here or none. And again, it produces float or none. And then I can look at how some of the other components do it. So for example, text box, how does text box do it? Well, text box, it basically says it return none if x is none, or return the string version of x. Okay, for slider, I should probably do something a little bit different. I can return none if x is none. So I can, if x is none, return none. That's fine. But if x is a value, then I should check to see if it's within the bounds, right? I should say if x is greater than self.maximum, or x is smaller than self.minimum, oops, not a function here, raise whatever value error, and GitHub Copilot is quite good at this. So it kind of completed the rest for me, but you'd write something like this. Else, return x, otherwise just return x. So so this kind of works here. And now what I probably want to do is I want to write a test for this. So I go to the test component, to the test repo. I go to test components, and I can find there's a whole set for, there's a class for testing sliders, and I can go ahead and kind of add a test to make sure that it throws the error that I just added. And so, you could do something like this, like def test slider invalid values or something like that, and then you could do I think that something like that. If I instantiate a slider, and then this is wrong, but let's do minimum equals this, and maximum equals this. If I try to pre-process a value that's greater than this, it should throw an error. So something like this, not 10, but let's do, 10 should work actually. Okay, and I can kind of write a couple of different tests if I want, and so that way, and once I have that, so I'm just gonna, then I run this. Now I've made a couple of changes to my files. Before you push these changes to your branch, what you should do instead, actually you might not be able to create, I'm trying to think, so you might want to make a fork. It's up to you. You might want to make a fork of the repo instead of a branch. You might need to do that if you're not an existing contributor. That's fine. Once you're ready, you kind of just push your changes, and open up a pull request. But before you do that, there's a couple of other things that you want to run as well. You want to format the backend. Okay, so this applies our linter and all of that stuff, formatter, and then you can push it. And if you want, you can run the Circle CI locally as well. And that's basically it. So once you do that, you'll open up a PR, and we'll review it. Someone on the maintenance team will review it and will respond. You'll also want to add a description of the change to changelog.md. That way other people can understand, and you can attribute it to yourself as well. That way other people know who made the change and what the change was. And then we'll review it. We usually review things pretty fast. And so we'll get back to you. We might ask you to make a couple of changes. And then if everything looks good, we'll go ahead and merge it in. And you'll be an official contributor to Gradio. And that's pretty much it. If you have any questions, feel free to reach out to me. I am probably most responsive either through the Gradio repo itself. So if you create an issue or if you open up a discussion, we're pretty responsive here. Or you can find us on our Discord. So that's also actually linked through here. Let me see if I can find this. So if you create a new issue, but if you have general questions, you can open up, and this will take you to our Discord. And we're pretty active there as well. So thank you so much. Thank you so much for being interested in making a contribution to Gradio and for listening to this video.